Hey guys, I'm back. Let's go ahead and finish up this game. We need the ability to be able to actually shoot the zombies and kill the zombies. So to do that, we need to give ourselves a gun class. So let's go ahead and create a gun class. All right, we're going to do C++ class and just call it gun. You might want to create a weapon class and derive gun from weapon in case you want to also have maybe melee weapons, grenades, something like that. But for now, I'm just going to go real basic and just have a gun class. So let's give it some private variables. So the gun is going to have a, we'll say an init function, or we'll just use we'll use the constructor. And it's going to need to set its properties. So we're going to have a fire rate property, and the fire rate will be how often it shoots, and we will measure that in terms of frames. That seems like the easiest way to do it. So int fire rate. We'll say fire rate in terms of frames. And we also need spread, so float spread. And this will be the spread of the weapon. So like how accurate it is. Accuracy. And finally, we need the number of bullets per shot. We'll put that up here. Int bullets per shot. How many bullets are fired at a time? Okay, so we need to pass in these properties whenever we construct a gun. And we should also give it a name, of course. So std string name. We will name our guns. So include string. And let's pass all the properties in. So we'll start with the name, underscore name. So we'll do std string name, int fire rate, int bullets per shot, and float spread. And let's grab this and drop it in the constructor of gun and set up all of the properties. I'll use an initializer list. Name, fire rate, and we'll do bullets per shot, and finally spread. All right, so this will set up our gun class, and there's nothing else in the constructor. Okay, and let's go ahead and create a fire method that will fire in a certain direction. So we'll say void fire weapon, fire gun. We'll just say fire. And this method is going to take a list of bullets. So it's going to add bullets to the list of bullets. It's also going to take a direction, so it's going to fire in a certain direction. And that should be all it needs. So we'll start with the direction, glm vec2 direction. And let's also pass in a vector of bullets. Now to do that, we need a bullet class. So let's go ahead and create ourselves a bullet class. Add class, and this will be bullet. There we go. All right, bullet, and we'll do private. It's going to need damage, so int damage. And it's going to need a position, glm vec2 position. And it's also going to need a direction. What else? Position, direction, and a velocity. So we'll do float speed. So that means we also need to have the damage and speed in the gun as well, because that'll determine the properties of the bullets that it creates. So we need int speed. We'll say bullet speed. And what was the other one? It was bullet speed and damage. And we need to include glm up here. .hpp. Speed and damage. So we'll say bullet damage. And we'll have damage be a integer. All right, so bullets, speed or velocity, or this is pretty obvious, we don't need a comment. All right, so we need to pass those in as well. int, oh, this should be a float bullet speed, my bad. Do we have a float? Yes, float speed. And you know what, let's just make damage a float, that makes more sense. No need for it to be a int. There we go. And gun, fire, what else? Yes, we need float, bullet, damage, float, bullet, speed. This will let us set up all of the properties we need. So let's add those to the initializer list. We'll say bullet damage is bullet damage, and bullet speed is bullet speed. All right, now we need to implement the void fire function. So we're going to get passed in a std vector of bullet. This will be bullets, not underscore. And it needs to be a reference parameter so we're not making a copy of it. And it will just have a direction, and we need to include vector up here, and we also need to include GLM. There we go. So let's go ahead and copy this to the CPP file. There we go. All right, so now when we fire a bullet in a given direction, we're going to apply the, let's include bullet up here. We're going to apply the properties to the bullet that we create, and we're also going to use the spread to determine how accurate it was and maybe offset it a little bit. The number of bullets per shot will determine how many bullets get fired, all that stuff. So we're going to fire, and what we should probably do here is, instead of just having a void fire function that we call publicly, instead we're just going to have a void update, and then we're going to say bool is mouse down. And if the mouse is pressed, then we're going to handle firing. That way the user can hold down the mouse and it will calculate how often it should fire by using the fire rate variable. So let's go ahead and add that. There we go. And so because of that, we have made fire a private variable, so only the gun can determine when it's going to get fired based on if the mouse is pressed. All right, so let's go ahead and store a counter. So we're going to say int frame counter, and we're going to start frame counter off at 0. 0. There we go. Now every time we call update, we're going to call frame counter plus plus. And if frame counter is greater than or equal to fire rate, that's when we fire. So at that point, we're going to call fire. And that reminds me, every time we update, we should also pass in these parameters so that we can actually pass it on to the fire function, of course. Go direction and bullets. Okay, so if frame counter is greater than fire rate and is mouse down, the mouse has to be pressed, then we're going to call fire with direction and bullets. And we are also going to set frame counter back to 0. Equals 0. There we go. So this will handle firing. Now we need to actually create the bullets and launch them in a certain direction. So what we're going to do is loop through the number of bullets that are going to be fired. So for int I equals 0, I is less than bullets per shot, I plus plus. So each time we get through this loop, we're going to spawn a new bullet. All right, so what we're going to do is say bullets dot in place back. And let's go ahead and set up the bullet constructor, because right now the bullet constructor isn't set up. We're going to need to give it a position, a direction, a damage, and a speed. So let's go ahead and do that. We're going to say, we just pass in all these variables, glm vec2 position, glm vec2 direction, float damage, float speed. All right, and we will copy this part, the parameters, into the CPP file and use an initializer list. Let's go ahead and say position, position, and we're going to say direction, direction, and we're going to say damage, damage, and we're going to say speed, speed. All right, that will set up all the variables. All right. And now we need to actually place it back. So we'll go back to gun. So the new bullet needs a position, a direction, and the other properties. So we do need to pass in a position. We need to tell the gun where it is. So what we're going to do is we'll pass that in the update function. And for efficiency, instead of making copies of these vec2s, we can actually pass them in as const reference. Just like that. That will use it as a reference so we're not making a copy, but it'll also make sure that it doesn't get changed. Because whenever you're passing a reference, you don't want it to get changed if it's not supposed to, or you're going to get some bugs. There we go. It's both update and fire. We'll use that. Okay, so update, we just added position, so let's copy that down right after isMouse down. Here we go, position as well. And the fire function will also need position. So copy that there. So this is what your parameter list should look like. So we're going to pass in position to fire whenever we do fire. And now we can actually emplace back everything we need. So the order of the parameters are position, direction, damage, speed. So let's do that. Position, direction, bullet damage, bullet speed. That will create the bullet and add it to the list of bullets with all of its needed properties. Now we also need to be able to draw the bullet, and we need to do collision with the bullet. Let's work on the draw function first, and let's also work on the update function. So void update. And update is going to handle collision with zombies and humans. So let's go ahead and pass in vectors for that. We're going to have forward declare human, and we're going to forward declare zombie. And let's go ahead and go to, we can just copy those parameters like this, because agent.h also uses them, save us a little time. Back to bullet.h. All right, update will have those. So let's copy this to the CPP file. This is bullet update. And we also need a draw function, so let's go ahead and do that. Void draw, and it's going to take a sprite batch. So let's include sprite batch. We'll pass it in as a reference parameter. Sprite batch, reference sprite batch. So let's copy this over as well to bullet.cpp, and we need to include vector up here. And I did it again. It's not spritebatch.h, it's Bengine slash spritebatch.h. What's going on here? Bengine slash, did I add it to the wrong, oh dang it. I added it to graphics tutorials? No, I didn't. What's going on here? Okay, it just wasn't giving me IntelliSense, so it was worrying me. All right, so we'll copy that into here. And now we can draw it. So for drawing it, we're just going to call sprite batch, sprite batch.draw. And for the destination rectangle, we're going to use position. So we're going to say glm, say vec2 or vec4, destrect. Now the position for the x is going to be position.x. For y, it's going to be position.y. And this is part of bullet, so we got to put that there. Position.x, position.y. And let's actually, when we draw it, let's offset the, what's going on here? Are we getting errors? No, we're not, we're fine. So instead of drawing with the position being at the top left, let's go ahead and offset it by the width of the bullet. Let's go ahead and create ourselves a variable up here, int bullet width, bullet radius. We'll just set that equal to 5. Bullets will be pretty small. So we're going to use spritebatch.x plus bullet radius and position.y plus bullet radius. And then of course the width and height will be bullet radius times 2 and bullet radius times 2. There we go. Alright, so there's destination rectangle. Of course we have const glm vec4 dest uv. Or sorry. Is that what it's usually called? Dest uv? uv rect. uv rect, and this is going to be, as always, 0.0f, 0.0f, 1.0f, 1.0f. So we'll pass that in. The texture, this is where we need to use our, resource manager again, our static resource manager. That should not be static, but it is. And we're going to get that texture with resource manager dot get texture, Bengine resource manager get texture, and the string is going to be textures / circle.png. We'll use circle again. There we go. And for the depth, we are going to say 0 as always. And for color, let's go ahead and create our color. We'll say Bengine color. Color.r we'll say is say 128. Color.g equals 128. Color.b equals 128. So let's make it even darker. We'll say 75. So our bullets are going to be a really dark gray. And then color.a equals 255, as always. And we'll just pass that in. Alright, so that will draw a bullet. And we need to include resource manager correctly. I always do this wrong. Bengine resource manager .h. And now it should be quiet. Of course, we have to say this returns a GL texture, but it also includes the width and height. We just need the ID, so we're going to say .id. All right, now we can draw bullets, and we can't update bullets yet. Let's go ahead and update them just with changing their position. So we're going to say position plus equals direction times speed. And we'll just do that every frame with all the bullets. So let's go ahead and make it so that we can shoot some bullets. Let's go ahead and give our player a gun. So here we are in player. We'll say, we'll give him the ability to cycle through different weapons. So we're going to say void add gun, and we'll pass in a gun. And let's forward declare gun up here. And then we'll have a vector of weapons down here. So a vector of guns. std vector gun pointer guns. And then we will have a gun pointer for the current gun. Or we can just use the index into the guns vector for the current gun. So we'll do that. We'll say int current gun index. And we'll start it out at -1. -1 means we do not have any gun. There we go. The initializer list. All right, and let's do that for conciseness. The reason I'm putting empty here is just so that it makes it clear that we are intending for this to be empty. All right. Now, whenever we add a gun, we will just pass it in and we will push it back to the vector of guns. So let's go ahead and do that. That happens under init. And we'll say player add gun, and we're going to say guns dot push back of gun. And let's also check if we don't have a gun equipped. Let's go ahead and automatically equip that gun. So if no gun equipped, equip gun. So if current gun index is equal to -1, then we're going to go and just set it to 0, since we know there's at least one gun in this. And this should only happen when there's only one, when there's 0 guns, and we add the first gun. Add the gun to his inventory. All right, so now in the update loop here, we can use the input manager to cycle through guns. So we're going to go ahead and we need to be able to, one thing our input manager has not implemented and we need to update it is instead of having an is key pressed and that's it, we should actually have an is key down and an is key pressed. This is key pressed is actually mislabeled. This is key down. We've just named it incorrectly. But in the meantime, we can kind of hack it by using some static bools. So we can say static bool. And to cycle through, actually, let's just use the number keys to cycle through weapons. That seems like the best way to do it. So if input manager is key pressed, SDLK 1. If the 1 key is pressed and guns.size is greater than or equal to 0, then we are going to select gun 1. So current gun index equals 0, like that. And we're just going to do this for all of them, for as many guns as we have. And right now we're only going to have, we'll say 2 guns for now. So we'll say SDLK1 and SDLK2 and gun index 1. All right, so now let's give the player some guns and let's test it out. We'll give him a shotgun and we'll give him a, oh, I don't think we actually implemented shooting correctly. So we do shoot in the correct direction, but we're not using spread. We need to use spread. So the way spread is going to do is we're just going to randomly offset the direction based on this spread variable. And to do that, we can go ahead and grab our random engine stuff. We'll copy this rand rotate because it's going to be pretty much the same thing. And instead of a static distribution, we're going to make a new distribution based on the spread. So we're going to go from negative spread to positive spread. And we need to include random. And we need to also include ctime, so we can seed the random number generator. There we go. So it's going to randomly rotate between negative spread and positive spread. And then whenever we do direction here, we're going to say glm rotate direction, and we're going to rotate it by rand rotate of random engine. And that will give us a little bit of a random spread here. And of course, to get that, we need to include glm gtx rotate vector.hpp. And that should stop complaining. I forgot a parenthesis there. All right, there we go. Now we have random rotation. So now let's give our player some guns. Let's go to init level. Set up the player's guns. All right, so let's go ahead and say we need to include a gun up here. Include the gun file. And let's give him a pistol, a shotgun, and let's also give him a machine gun. So let's do 3 keys here. We also have SDLK 3, 2, 2. Back to main game, set up the player guns. Player, add gun, and we're going to say new gun. And the parameters are first the name. We'll start with pistol. Fire rate, we'll say magnum. Fire rate will be 30. We can change this. Bullets per shot 1. Spread, we'll say 10. Bullet damage, let's go ahead and go with 30. Right now the zombies don't have health, but we'll add that. And bullet speed, let's go ahead and go with 20. Should be good. All right, and that's the first gun. Let's also do shotgun, and we'll do MP5, which is a type of submachine gun. All right, so the shotgun's fire rate is going to be even longer than the pistol. We'll do 60. I just realized we don't have ammo requirements, but I guess we're just going to pretend like all of our guns have infinite ammo for now. You can always add that in. Bullets per shot, we'll do 20. Let's see, this is the, what was this one? Spread, it's going to be much more spread. We'll say 40. And bullet damage, we'll say 3 per bullet. We'll say 4 per bullet. And bullet speed, same, we'll go with 20. We'll go 20 for all of them. Bullet speed equals 20. We'll just assume they have pretty much the same muzzle velocity. And the MP5, we're going to shoot it much faster. It'll have a fire rate every 5 frames. It'll shoot a single bullet. It'll do, we'll say, the same damage. We'll do slightly less damage than the Magnum. Do 7 damage. And what was this last one? No, the bullet damage is this one. Oh, this was the spread. It should have more spread than the Magnum. We'll say 20. And the bullet damage, let's go with 20 bullet damage. We'll say 20. Whatever. It doesn't have to be perfect. All right, so now the player has guns, and we're going to be able to shoot those guns if we, let's see, player.update. We need to update his gun. So let's go ahead and do that. If, or we're just going to call if current gun index is not equal to -1, so he needs to have a gun equipped. Then we're going to say guns, current gun index, update. Now we need to pass in if the mouse is down, and that's just going to be SDLK is key pressed, SDL mouse, or SDL button left. That stands for the left mouse button. All right. And then it also takes the position, so we're going to say we'll start at the player position plus, and we need to make sure we add his dimensions, remember, because his actual position is in his corner. We need to push it to his middle. So we're going to say GLM vec2, and this will be agent radius. So make sure it's starting from the center of his body. Now the direction is going to be, the direction will be the player direction, where the mouse is, actually. We're going to be shooting towards the mouse. So what we need to do is get the position of the mouse and store that whenever we are moving the mouse around. And I don't think are we actually storing it in the input manager? I think we are. Input manager, what do you got? Get mouse chords, that's exactly what we want. So we're just going to ask the input manager for the mouse chords. So let's go ahead and calculate that vector. So GLM vec2 direction, and let's say GLM vec2 mouse chords equals, and this is going to be input manager dot get mouse chords. There we go. That'll get us the coordinates of the mouse. All right, and I believe we need to use our window to determine exactly where the click is happening. We've done this before. We used our function. Where is it? I thought we made a function for that, for determining where the mouse chords were in the window. I thought we already did this. Give me just 1 second. Right, we aren't using the window. We are using the camera to convert screen space coordinates to world space coordinates. So we need to use the camera for that. We're going to have to pass a few more things into the player, it seems. All right, so let's go ahead and we need to get, so we have the mouse chords, and we need to convert the mouse chords to the actual world space coordinates. And to do that, we need a handle to the camera. So we need to, whenever we initialize the player, we need to pass in the camera as well. So Bengine camera 2D. Let me just include that up here. 2D.h, I believe is what it is. Camera 2D, and we'll say camera. And let's store that here at the bottom. And this is camera. And we'll set that in the init function. We'll say camera equals camera. All right, so now we can correctly determine where in the world we clicked by using mouse chords equals camera underscore camera. Convert screen to world. And I believe that does return a vec2. Yes, it does. And we're just going to pass in mouse chords. So that'll do the conversion. And now we can get the actual direction to the click. So what we're going to do is, first let's get the actual player direction, or player position, center position, and that's going to be equal to this value we made right here. So we can change this to center position. All right, so direction is going to be equal to mouse chords minus center position. And that is the direction vector. And of course we need to normalize it so that it has unit length. So we'll use glm normalize there. And I will comment this all out for sure whenever I put it online for you guys to use. Okay, so now we have direction. And finally we need the vector of bullets. So that means we are going to need to pass in the bullets vector as well to player.update. This should be the last vector we need to pass in. Vector of bullet star bullets, and we need to forward declare bullets up here. All right, and we need to include bullet in the CPP file. And now we can have it passed in and just pass it on to the gun so that the gun can handle adding bullets to that list. And let's see, is there anything else here? Input manager, what's the problem? It's underscore input manager. And guns, incomplete class type, because we did not include gun up here. Remember, with a forward declaration, if you don't forget to include it in the CP file, you're going to get that error right there. Let's see. Reference is not initialized with... What's the problem here? Because we have a... Well, no. What's the issue? Reference of type std vector bullet cannot be initialized with a value of type. Oh, right. Because this is bullet star, but we said bullet instead of bullet star up here, didn't we? Yeah, because... Right. We're not going to make bullets be a vector of pointers. Bullets is just a vector of bullets. Since bullets are pretty small in memory, we should not use pointers and not use new and delete, and instead just keep it like this. This is going to cause our data to be contiguous in memory, and it'll give us better cache coherency. I haven't actually given you a tutorial on that, but just know that it will be slightly faster in the bullets case if we just pass it in not as a vector of pointers, but as a vector of bullet classes. Okay, now we should be able to actually shoot bullets, but we are not drawing or updating the bullets, so we need to do that in the main game real quick. So let's go to update. We don't have a bullet vector, so we need that. std vector bullet bullets. And since it's not a pointer, we have to include bullets. You can only do a forward declaration when it's a pointer. So include bullet.h. That means we also need to do the same thing in the player, which we did not do. So stop that forward declaration, then we don't need to include bullet again in the CPP file. All right, so we have our vector of bullets right here. And what we should do is update all those bullets. And we're going to do that in the game loop. Update bullets. Let's just make an update bullets function. Put that under update agents. I'm going to keep our main game loop as small as possible. And we'll put that under update agents. So let's just call update bullets here. And all right here, void main game, update bullets. All right, and now we can loop through all the bullets for int I equals 0, I is less than bullets dot size, I plus plus. And we're going to say bullets I dot update. And whenever we update a bullet, it requires humans and zombies. There we go, and that updates it. Now we want to draw them, so let's come down here to this right here. We'll go ahead and use agent sprite batch. Even though it's called agent sprite batch, it's actually not just for agents. So draw the bullets for int I equals 0, I is less than bullets.size, I plus plus. And we're going to call bullets I draw. And this is actually a dot draw. And we're going to pass in agent sprite batch, and that should draw all of our bullets. All right, let's go ahead and see what happens. Hopefully it'll work. Our shooting direction might be slightly wrong, as it often is, but we will be able to fix it pretty quickly. We forgot to pass in the camera. We need to pass a pointer to the camera, because the player needs that resource. A little bit of dependency injection right here. All right, what's the issue? Bullet radius already defined. So we have, let's make that constant. That's the issue right there. Constant bullet radius equals 5. There we go. All right, so now it's running really slow and it's not letting me move, so I must have messed something up in the player update function. Let's go ahead and go here and see what's going on. Player.cpp. And where are we? Player update. What is going on here? What did I do? Let's toss a breakpoint in here, just to be sure nothing's going on. When I press W, we should get a breakpoint, and we are getting nothing. We cannot move anymore. That means we probably aren't ever even calling update. Let's try that again. All right, we're not updating the player anymore. How did I do that? Let's see. Let's go back to update agents. Where do we update the player? Did I accidentally delete the player update? No, because player is one of the humans, so he should be getting updated there. Oh, right. So we changed the player update function to require a vector of bullets. That's right. So it's no longer inheriting from human. This virtual void, it's no longer overriding this. Now, to prevent a bug like this from happening, what we can do is type override, since we're in C++11. And if we put that there, now when we try to run it, it's going to tell us we're not overriding a function because we actually changed the definition and this is a different function. So we messed up there. So the easiest way to do this is just to, instead of passing it in like that, what we're going to do is pass it in as a, say, a pointer to bullets, and we'll store that. So we'll store a pointer to those bullets. Just a little bit more dependency injection. That way we can reuse the same update method. And so that means we need to go to player.cpp and change it there as well. And we'll just say bullets equals bullets. And then since the update function is expecting a reference to a bullet class, not a pointer, we can dereference this bullets pointer like this with the star. And we'll say underscore bullets. And that will pass in a reference to the dereferenced value. So now we can run it and we should be able to walk around. Oh, nope. What's up? What's up? Ooh, I must have messed something up. Oh, there we go. Gotta get rid of that. What else? Aha, bullets. So we're going to pass in the address of bullets. All right, now we can move around again, and we can shoot bullets. And the bullets are getting shot very slow. We are running a little bit slowly right now. It was slower than it was before, probably because of the new collision and stuff. We just lost the game. Let's go ahead and reduce the number of people. Let's go to documents, the thingy, projects, graphics tutorials, Bengine, graphics tutorials. No. Zombie game. Levels, let's modify level 1 to have fewer people. We'll just change it to 100. We will do optimizations in the next few tutorials and make it so that we can have a lot more. There we go. So now that there's fewer players, it runs a lot smoother. Now the bullets don't collide with anything. We are going to need to program a little bit of collision in for the bullets, but the bullet collision will be really easy. We're just going to do a point against a box collision and a sphere collision. And we'll implement that in the bullet method. Let's increase the speed of these guns and let's try using our different guns. So let's see, we have, where's the speed? The speed is the first one. So the fire rate for Magnum is 30. I think the shotgun should be 30. The Magnum should probably be 10. And the machine gun should be like 2. Let's try that. Alright, so there's the pistol. There's the shotgun. Pretty neat, huh? And then here is the machine gun. Let's equip the machine gun. Oh, I am not able to equip the machine gun, it seems. Cannot equip the machine gun. Let's see what's up with that. Let's go to player.cpp. Oh, how did that happen? There we go. Now let's equip the machine gun and see what that looks like. There's the machine gun. It's a little bit inaccurate. Let's change the accuracy of the machine gun and the shotgun. Let's go back to main game. And let's go to, here we go, the MP5. Let's change the bullet spread to be half of what it was. For the Magnum, let's change it to be half. And for the shotgun, let's change it to be half. And instead of 20 bullets, let's just do 12 bullets. Alright, so now we have guns. Let's actually utilize those bullets and do some damage and kill some zombies. So to do that, we're going to need to give health to our agents. So let's give them a health property. We'll say float health. And this will get passed in whenever we initialize our agents. We're going to, actually it doesn't even need to get passed in. We can just set it in the init functions. So the human's health, let's set a human health to be 20. So it's really easy to kill a human. So you don't want to shoot your own guys, of course. And let's go to, what is it, zombie. Let's give zombies, we'll give them 150 health. We'll give them quite a bit of health. Zombies are tough. Do that in the init. Health equals 150. And we're not going to give the player, like we can give the player health, but it won't matter right now because the player is not going to be getting shot at. We're not going to do any bullet collision with the player. We're going to say health equals 150. Now, to make sure that the bullets do not collide with the player, we can do one of two things. We can make sure the bullets don't spawn in the player, or the even easier method is just to make sure that when we do bullet collision, we don't collide with the first human, because remember, the first human is the player. He's the very first human we create. All right, so let's do some collision. Let's go to gun.h, or sorry, bullet.h, and we're going to say bool collide with agent, and it will return true if we collided. And we're going to collide with an agent, so it's just going to be agent star agent. And let's copy that to the CPP file. There we go. And this belongs to bullet. And we're going to do some very, very simple spherical collision here. And we should also collide. We should also collide with the world. Let's start by colliding with the world because that's going to be even easier. It's a very, very simple collision. So much easier than the other world collisions. Let's forward declare agent and include agent. We also should include human and zombie. And include zombie. There we go. And actually, so we are passing in humans and zombies to the update function because we were going to do the collision in the bullet, but it would be better to do the collision in the main game so that we can manage the list. So we'll do it that way instead. So we'll stop, whenever we update, stop passing in humans and zombies. And we need to do that in the main game as well. Update bullets is up here. Oops, passed it. So just call update. Update bullets will also handle collision. All right, so back to bullet.cpp. Now, whenever we collide with an agent, we're going to just do spherical collision, or actually an even simpler spherical collision. I guess we'll just do spherical, that's fine. And then when we collide with the world, what we're going to do is, we'll do that here. Void collide or bool collide with world. And whenever we collide with the world, we're just going to check what tile we're on, and if it's solid, we're going to call it a collision, and we're just going to delete ourselves. Really simple. So we're going to need to pass in the world data, so std vector, std string, and this will be level data, and we don't want to modify the data, so we're going to make it constant. Now, if we did want to modify the data, like so we could blow holes in walls, then we might make it non-constant. But for now, we're going to go ahead and just do it this way. It's much simpler. And that means since update is going to do collision with the world, we should pass in the level data to update as well. Like that. And we don't have the method, so let's copy it. Is that in the right order? Yes. Now what we should do is, whenever update returns true, we will delete the bullet. So when update returns true, delete bullet. So we're going to say bool update instead of void. So we're just going to return collide with world of level data. So whenever we collide with a level, it returns true, and the bullet gets deleted. Now to collide with the world, we just need to find our current position. So we're going to say glm vec2, and this is going to be, this is actually an ivec2 since it's an integer position. ivec2, and this is grid position. So grid position dot x equals position divided by, and remember we need tile width, and is this an int? We need to include level. Let's do that. Tile width is defined in level. So let's divide it by float tile width dot x. And we can actually do both at the same time. We can say position y. No, we'll do it this way so that we can use floor. The floor of position x divided by tile width, and grid position dot y equals floor of position dot y divided by tile width. All right, and now we need to check if we went out of bounds. If we went out of bounds, we're going to go ahead and return true. So if, and let's just copy this from the agent collision, which is an agent.cpp, so we don't have to type it all out. Got to do our bounds checking, which happens right here. So back to bullet. And instead of corner position, it's grid position. So if that's true, we're just going to return true, meaning delete the bullet. Otherwise, we're going to check if the level data at grid position y x dot y dot x, we're going to check if that is not equal to a dot. If it's not equal to a dot, then that means we collided. So this is a Boolean expression. It will be true whenever it's not a dot for collision. So we'll just return that Boolean expression. You can do that. It's pretty nifty. All right, so that's that. Now we can collide with the world. Let's go ahead and see if this happens. We need to make sure when we update our bullets, we pass in the level data. So levels, current level, get level data. Here we go. Let's run it. And the bullets should collide with the walls. If they go out of bounds, if they somehow phase through a wall or something like that, which they shouldn't, then we should return. We'll just return true here. You have to return a value or you'll get an error, even though we're not doing collision yet. All right, so now we are not getting collision with the wall, it seems, at all. Oh, we are getting collision with the wall. We're just not doing anything about it. So if bullets I update, remember, this is true. So if update returns true, the bullet collided with a wall. So in that case, we should delete the bullet. So remember, we can say bullets I, this trick, equals bullets.back, and we don't need to delete the bullet because we didn't allocate it with new. And then we're going to say bullets.popback. And remember, if we do it this way, we're going to end up skipping one of the bullets. So instead, we're going to get rid of I++ here and move it into an else statement, I++, so that whenever we do delete a bullet, we don't increment I, so that we make sure we update that back bullet that we swapped in. Now let's see if our bullets will collide with the walls. There we go. The bullets hit the walls and they stop. All of our different kinds of bullets, our machine gun, our shotgun. Shotgun is very slow. It's pretty neat. Now we just need to be able to shoot monsters or shoot zombies and we will be done. So let's go ahead and do that next. Now we update the bullets here. Now we need to update the bullets for collision. So let's go ahead and loop through all the bullets. And we can actually, we'll just do a separate for loop. So collide, update, and collide with world. And this is going to be collide with humans. And then we'll have collide with zombies. So for int I equals 0, I is less than bullets.size, I++. We'll just say collide with humans and zombies. We can do this in one loop. Now we need to loop through the zombies, so loop through zombies. So for int j equals 0, j is less than zombies.size. I'm going to say j++, and we're going to say if bullets I dot collide with agent of zombies I. So we're going to try to collide with the zombie that we are currently looking at, zombies j. If we collide, then we're going to damage the zombie, and kill it if it's out of health. There we go. And let's go ahead and say check collision. All right, so that's zombies, and we'll just copy this. We'll do zombies first. For now, we won't be able to shoot humans. Now we need to implement collide with agent. So this is going to be just the same exact spherical collision we did in agent.cpp. So let's just copy it. It's pretty much it's going to be the exact same thing. So we're going to copy this. We're going to go to bullets dot collide with agent. There we go, and we'll paste that. And the only difference is we're not going to be changing any positions here. We're just going to check the collision, and if there is a collision, we're just going to return true. Otherwise, we're just going to return false. It's even simpler than before. Now here, the only difference is tile pos. What is tile pos? Where did we get that? Oh, this is collide with tile, not collide with, my bad. We need this one, collide with agent. Not collide with tile. I keep clicking on the wrong files. All right, collide with agent for the bullet. We're not going to change their positions here. Here we're just going to return true. We don't even need the collision depth. That doesn't matter. We're just going to return true if there was a collision. And min distance is agent radius plus bullet radius. Bullet radius. Not agent radius times 2, because the bullet is a different size than the agent. Okay, so if we collided with the agent, first we're going to remove the bullet. Like that. And again, we don't need to do I++ here. So what we're going to do is we're just going to call continue at the bottom here. That will skip anything else. Actually, we can break. We don't need to loop through the zombies anymore. So let's just see. All right, so we have removed the bullet. Now we need to damage the zombie. So we're going to say zombies, J, arrow, and we need to be able to damage it. Let's go to zombie.h. Actually, we can go to agent.h. This is going to be something that all agents can do. We're going to say bool apply damage, and apply damage will return true if we died. Really simple. And we're going to say float damage. So we're going to grab this, go to the below the draw function, paste it right there, say that it belongs to agent, and we're going to say health minus equals damage, and if health is less than or equal to 0, then we died, so return true. Otherwise, we return false because we did not die. Back to main game. So we can say if zombies J, make sure you're using J here and not I. That's going to be a really hard bug to spot if you do that. Make sure you check all of your for loops for this. If zombies I dot apply damage, and this is going to be bullets I arrow or dot get damage. Now, since we're trying to get the damage from the bullet here, we should probably not do it until we should probably not delete the bullet until after we do that. Let's go ahead and write the get damage function because we do need that. So float get damage. This will be constant return damage. There we go. So if we apply damage to the zombie, if the zombie died, remove him. And here we're going to say delete zombies I, and then zombies I equals zombies.back, and then zombies.popback. Zombies.popback. There we go, and since, I did it. I did the bug. It's zombies J, not zombies I. Make sure you do that. Now, here we don't want to increment J every time, just like before. We only want to increment J right here, J++, and right here, else J++, like that. In addition, whenever we remove a bullet, we can go ahead and move on to the next bullet. So we don't need to, or we do want to not call I++. So yeah, same thing. We don't want to call I++ here. We only want to call I++ here. Actually, yes, so what we want to do is when we remove the bullet, we don't want to go to any more zombies. So we're going to call break here. What break is going to do is it's going to stop iterating through the zombies. Since the bullet died, no need to loop through any more zombies. And this will not call I++, which is good. What we're going to do is call I++ out here. So if we reach this point right here, next bullet. If we reach this point, that means the bullet was never deleted, so we're going to move on to the next bullet. Right here, if the bullet does get deleted, we don't want to call I++, and this break will skip that. Oh, no, it won't. No, it won't. All right, so it seems like the easiest way to do this is to just have I++ here, and then whenever we remove a bullet, we're going to say I minus here. Make sure we don't skip a bullet. Sorry for the confusion, guys. All right, now we should be able to shoot zombies. Let's see what happens. All right, I can't shoot people yet because we haven't implemented that, but I can shoot zombies, and they do die. There we go. Now we just need some cool blood effects or something. Now it looks like the collision isn't correct. As you can see, I can shoot through the side of it, and then I'm colliding a little too low, it seems. And a little too far to the left. Let's find another zombie. Oh, I killed them all. It's okay, let's start again. See, is it too far to the left? Definitely too far to the left and too far down. Let's figure out what the reason for that is. Let's go into bullet collision and collide with agent. So this is the issue. So here's the issue. Center position A, this is the position of our bullet. We're adding agent radius here. We should be adding bullet radius, not agent radius. And actually, since we're rendering it so that the position is the center of the bullet here, I do believe we can just ignore this right here because we're treating that position as the center of the bullet whenever we render. And I believe when we start the bullet off, we do start it in the correct place. So let's try it. It should be good now. Get out of the way. There we go. Now we're getting proper collision. That's good. Awesome. So we can kill zombies. This is pretty much the basic requirements of the game. Let's go ahead and finish it up. We're almost done. We need to collide with humans too. We need to be able to kill humans. And we'll record some stats. So and then we need a win condition. And in future tutorials, we'll do things like add blood effects, we'll add text, we'll add sound, we'll do all sorts of cool things. We'll definitely optimize it. We want it to run a lot faster. We'll have a whole tutorial devoted to making it faster. All right, so this is loop through zombies, and then we need loop through... well, darn. I just realized that this I minus minus isn't going to cut it, because that's going to cause us to process. Yeah, let's just do two separate for loops. For no, that's not smart. All right, we're gonna have to do it this way. Instead of calling I minus minus here, we're going to go ahead and well, let's just have a bool. This is the easiest way. Bool was bullet removed equals, and we'll just set it here. So at the very beginning, we're going to set was bullet removed equals false. When we remove a bullet, we're going to say was bullet removed equals true, so that when we come down here and loop through humans, if was bullet was removed is true, then we're not going to loop through all the humans, because there's no point, the bullet's gone. So if was bullet removed is equal to false. That's what we're trying to say, actually. If that is false, then we're going to loop through all the zombies. Or all the humans, sorry. So let's change every occurrence of zombies to just humans. There we go. And damage human. And now to remember, to keep the bullets from colliding with the player, we're going to start, instead of j equals 0, we're going to say j equals 1. So that we don't loop through the player and accidentally collide with the player. We don't want to do that. All right, let's see if we can kill people. Ah, we can, and they die really fast because they're weak. Awesome. All right, so now let's record some stats and let's make sure we have a win condition and all that. Let's see. Int num humans killed. This will be humans killed by player, so we can see how bad we are. Player. Int num zombies killed. Zombies killed by player. And we'll do int humans remaining. Actually, we don't need that. We can just say humans.size. All right, so let's initialize these to 0 up in the constructor. And num zombies killed, 0. And anytime we kill a human or a zombie, we're just going to increment these, really basic. So here we go, delete humans. Uh-oh. What's this? Oh, right, this is turning humans into zombies. So we're not going to put anything there. We need to go to update bullets. So when a zombie dies, we're going to say num zombies killed plus plus. When a human dies, we're going to say num humans killed plus plus. There we go. And now we need to check some victory conditions. So before draw game, or we'll just say after update bullets, we're going to say check victory. Actually, let's do it after draw game, so we'll do it at the very beginning. Check victory. And we'll make this function right above process input. Check victory. This checks the victory condition. And we're going to put that right above process input. Void check victory. And now we need to, oops. And it's as simple as if zombies.size is equal to 0, which is the equivalent of saying if zombies.empty. A little more concise way of saying it. All right. If all zombies are dead, we win. All right, and if that's the case, let's just do a fatal error. Even though we shouldn't be using it this way, but that's what we're going to do. we're going to fatal error with you win. We'll do that at the end, but first let's print out some stats. Or no, we'll just do a fatal error with nothing. That'll stop the game and end it. Let's print out some stats. So std, we'll do printf. You win. New line, and let's give it a bunch of stars. Make it pretty. And you killed %d humans and %d zombies. There are %d out of %d humans remaining. And let's pass in all these variables. So you killed num humans killed and num zombies killed. And then for the number of humans remaining, we are going to do humans dot size -1, because remember the player counts as a human. And let's say civilians remaining, because you're trying to save civilians. And the total number of humans is levels, current level, arrow get num humans. There. And that will do the you win printf, and this fatal error will just prompt us to press any key to continue and end. Now you'll notice, remember we use levels, current level. Now we only have one level, but what you should do is, we'll put a to do here. Support for multiple levels. So we would say something like current level ++, and then we would, init level, whatever, initialize the level. So that's a little to do for you to work on. What about multiple levels? All right, now let's try to win the game and see if we get a proper printout. We'll kill a few humans, we'll kill a few zombies, see if it tells us anything. All right, let's just mow these guys down here. Just killing everybody. All right, let's fly over. We're at the top right-hand corner. We should see some more zombies. And once we kill the last zombies, we should get a little print statement. And let's go over here. We're getting close. I can feel it. It's a pretty big world. I can't wait for the optimizations so we can have a lot more zombies and things. Oh, all right. Oh, we should also put a mini-map at the top right-hand corner. I believe the original zombie game did that. Oh, they're too strong. Good thing I have infinite bullets and I don't have to reload. This guy's waiting for me. All right, where are the rest of them? They're spreading. All right, here's some more. Oh, God. Don't worry, guys. I'll save you by shooting you so you don't become zombies. Oh, man. I cannot let them pass this center position because I don't know where they are. I don't have a mini-map. Ah, up here. What are you doing up there? All right. This is going to be actually pretty hard, I think, to make sure we kill all the zombies without a mini-map. That's why a mini-map is so useful in the other games. All right, let's go up in the middle. Just going to shoot randomly just in case. Are there any zombies left? Ah, there we go. That was one. Excuse me, sir. Excuse me, sir. Uh-oh. No! They're spreading! I'm failing to contain. We need a quarantine. Uh-oh. I can't kill them fast enough. Yes! Alright, I killed 18 humans and 35 zombies. There are 49 out of 100 civilians remaining. So we didn't do too great. We lost over half the population of the city, but our game works. It's very basic. We of course have a lot of cool stuff to do. We're going to add blood effects. We're going to add sound. We're going to add everything else. We'll do that in future tutorials. We will use this game as a kind of starting off point for the future tutorials. So I will teach you more about game development. We're going to optimize this. We're going to improve the code. We're going to do all sorts of cool stuff. So thank you so much for watching, guys. If you want... make a video of your game. Hopefully you made a game kind of like mine, but a little different, or maybe even totally different. Make a video explaining your game, maybe walk through a little bit of a code for us, submit it as a video response, and I would happily put it in the description, and I'm going to definitely rank my favorites. I'll make like a top 10 list or something like that, so please do that. I'll go ahead and comment this, and you will find the source code in the description. If you have any questions, don't hesitate to ask. Hopefully this wasn't too confusing for you. I know it was a very, 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 very long little game creation thing, but we did get a lot done, and we did create this game mostly from scratch using all of our library functions that we have already made in the previous tutorial videos. Thanks for watching, guys. I will catch you in the next tutorial. Hey guys, I just realized I had a quick bug. I want to make sure you guys know this. Whenever we're checking for collision between between an agent and a tile, we have if x depth is greater than 0 or y depth is greater than 0. This should actually be an and. We need to have a collision in both x and y direction to actually have a collision. Now it seemed to work fine even without the and, but that is definitely an issue. And do we do this in Bullet or anywhere else? No, it looks like we're good. Yeah, so I just wanted to let you guys know. Thanks. We also forgot to allow the player to exit the game. Now this is pretty important. You probably figured this out on your own, but in the process input function we should be saying game state equals game state : exit. We got to make sure the game will exit when we press the quit button. So now when we run it, if we hit the exit button at the top right, it will quit the game. It didn't do that before. My bad. Alright, one last thing I promise. In the destructor for main game, make sure you delete any remaining humans and zombies at the end of the game. Now, since our main game ends when the program ends, even if we did forget to do this, it wouldn't really be a problem. But if we were running multiple instances of main game, this would end up being a memory leak. So don't forget to do that. Always have a delete whenever you have a new. Thanks, guys.